Chapter 1: Introduction to SAP and its Architecture. Company origins and vision. SAP's journey began in 1972, marking a significant milestone in the evolution of enterprise software. The company was founded by 5 former IBM employees in Waldorf, Germany, with a clear mission to revolutionize business software solutions. 1. Name, systems, applications, and products in data processing. 2. Initial vision, to create pre-packaged business software solutions for organizations. 3. Original focus, real-time data processing aimed at enhancing business efficiency. Early architecture. The first SAP architecture, known as A1, represented the initial effort to create enterprise software for managing business processes. 1. Design, single-layer architecture. 2. Database interaction, direct, with limited user interface capabilities. 3. Focus, real-time processing, which was ahead of its time in ensuring businesses could access and analyze data instantly. Chapter 2: Evolution of SAP Architectures. A1 architecture. 1972. SAP's journey started with the R1 architecture, which was foundational but quite basic. 1. Database interaction, direct access to databases, requiring complex user operations. 2. Scalability, limited scalability, which posed challenges for growing businesses. 3. Real-time processing, the ability to process data instantly was a core feature, though limited by early system constraints. R2 architecture. 1979. SAP's A2 architecture introduced a major improvement. 1. Two-layer system, divided the system into a database layer and a presentation layer. 2. User interface, enhanced user interface and improved usability, making it easier for users to interact with the system. 3. Presentation layer, the introduction of this layer allowed SAP to focus on providing a better user experience. R3 architecture. 1992. The R3 architecture represented a revolutionary leap with a 3-tier design. 1. Presentation layer, managed the user interface, provided client-side processing, and handled data visualization. 2. Application layer, responsible for business logic, data handling, and system operations. 3. Database layer, focused on data storage, retrieval, and maintaining data integrity. This architecture set the foundation for what SAP would become today and was adopted by businesses globally. HANA architecture. 2020. In 2020, SAP transitioned to HANA architecture, which significantly transformed its operations. 1. Transition from third-party databases. SAP introduced its own SAP HANA database for faster processing. 2. Two-tier structure, streamlined the application and database layers, focusing on enhanced processing capabilities and improved efficiency. Chapter 3: Impact and growth of SAP. Global expansion. SAP's growth has been impressive, with several key milestones. 1. R3 adoption. SAP's A3 architecture became a global standard, enhancing its reach. 2. Indian IT sector boom. Post-1995, SAP saw significant growth in India after the IT boom, with more companies adopting the system. 3. IntelliGroup in India, 1998, a turning point that led to a broader implementation of SAP solutions across Indian businesses. 4. Entity data acquisition, further expansions through mergers and acquisitions, driving SAP's market presence. Industry evolution. As SAP grew, so did the implementation industry. 1. Satyam's 2008 downfall. The challenges faced by consulting firms like Satyam led to the rise of new implementation partners. 2. New implementation partners, companies like Accenture, Capgemini, and Deloitte took over as major players in the SAP implementation industry, contributing to SAP's widespread adoption. Chapter 4: Application layer. Deep dive. Core processes. SAP's application layer is at the heart of its operations. Key processes in this layer include: 1. Dialogue process handles real-time user interaction, facilitating two-way communication. 2. Background process manages long-running tasks, scheduled jobs, and resource optimization. 3. Spool process manages print jobs, formats output, and handles queues. 4. Update process ensures smooth database modifications and transaction handling. 5. In-queue process manages locks, preventing deadlocks and ensuring sequential updates. Essential services Several essential services support the SAP system's functionality. 1. Message service manages load balancing, server distribution, and resource allocation. 2. Gateway service facilitates external communication, system integration, and data exchange. Chapter 5 SAP Landscape Components System Classification. SAP systems are categorized into three key types, each serving a different purpose. 1. Development systems, used for customizations, feature development, and testing new changes. 2. Quality systems, focus on validating changes, integration testing, and performance verification. 3. Production systems, handle live business operations, processing real-time transactions for critical business processes. Naming conventions. SAP adopts a systematic approach to system identification, often incorporating 1. Department identifiers, denoting specific department usage. 2. System type indicators, indicating the system's role, for example, development, testing, production. 3. Sequential numbering, to distinguish different system instances. Implementation example, BMW case study. 1. Module distribution, how BMW distributed SAP modules across different departments. 2. System integration, detailed integration of various modules for smooth operation. 3. Department coordination, coordination efforts for efficient business process execution. Chapter 6 Testing and Data Movement. Data flow management. The movement of data through SAP involves several stages. 1. Development initiation, customizations and code developments. 2. Quality assurance, ensuring the changes are properly tested. 3. Production deployment, the final stage where changes go live. Environment types. SAP environments are structured for various stages of the process. 1. Sandbox environment, used for experimentation and risk-free testing of new ideas. 2. Development environment, where customization work and code development occur. 3. Quality environment, used for integration testing, user acceptance, and performance validation. 4. Production environment, the live environment for real-time business transactions and operations. Chapter 7 Real-world SAP landscape. Interview. Focus areas when engaging with SAP professionals. Focus on 1. System architecture, understanding the core components and layers of SAP. 2. Module integration, how different modules communicate and work together. 3. Team structure, the organization of SAP implementation teams. 4. Implementation methodology, best practices for implementing SAP in business environments. Client organization. Understanding. For successful SAP implementation, it is essential to understand 1. System composition, the structure of the SAP system used by the client. 2. Module distribution, how various SAP modules are distributed across the organization. 3. Team hierarchy, understanding the team structure and roles within the client's organization. 4. Operational workflow, how SAP is integrated into the client's daily business processes. Chapter 8 Interview Preparation Guides. Technical knowledge. Key areas to focus on during interviews. 1. Architecture understanding, in-depth knowledge of SAP's layered architecture. 2. System integration, how SAP integrates with other systems. 3. Module functionality, understanding the core functions of SAP modules. 4. Team dynamics, how the team is organized for implementation and ongoing support. Client experience, key documentation and areas of focus for interviews. 1. System details, a deep understanding of the client's SAP setup. 2. Project scope, the extent and goals of the SAP implementation. 3. Team structure, the roles and responsibilities within the client's team. 4. Implementation challenges, common challenges faced during the implementation process. Chapter 9, Future Outlook. Technological evolution. Current trends shaping SAP's future include: 1. HANA architecture adoption. The transition to SAP's in-house database is enhancing speed and performance. 2. Cloud integration, moving SAP systems to the cloud for increased scalability and flexibility. 3. AI and machine learning. The integration of AI will enhance business processes and decision-making. Industry impact. 1. Business process automation. SAP is evolving towards more automated processes. 2. Real-time analytics, increasing the focus on real-time data analytics for smarter business decisions. 3. Intelligent enterprise, moving towards intelligent systems that integrate AI and machine learning. 4. Digital transformation, how SAP is enabling businesses to undergo digital transformations. Implementation strategies. Modern approaches to SAP implementation include: 1. Agile methodology, a flexible approach that allows for quicker, iterative changes. 2. DevOps integration, bridging development and operations for faster deployment. 3. Continuous improvement, fostering a culture of constant evaluation and optimization. 4. Innovation focus, prioritizing new technology and features to keep SAP implementations ahead of the curve.